Alright, hello and welcome to another Math Counts problem tutorial. So today we will be looking at problem number 26 in the 2011 chapter Sprint. So let's read through our question. If a committee of 6 students is chosen at random from a group of 6 boys and 4 girls, what is the probability that the committee contains the same number of boys and girls? Express your answer as a common fraction. So the main concept that we need to know here is about combinations. So let's say that we have a group of let's say that out of the 6 boys, so let's say A, B, C, D, E, F. So we want 3 boys, 3 girls for it to have the same number. So here we want 3 out of these 6, but order does not matter. So A, B, C is the same as C, B, A. So what we want to do is a thing called choosing. So if we have A choose B, then essentially what we get is A factorial over B factorial times A minus B factorial. If you don't know what a factorial is, then let's say 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. A relatively simple function. Alright, so let's do our question. So we have 6 boys and we want to choose 3 of them. So then we do 6 choose 3, which is equal to 6 factorial over 3 factorial times 3 factorial. So the way we would calculate this is to expand and cancel terms. So we end up with something like this, and you'll see that we have a 3 times 2 times 1 in both of these. And 3 times 2 times 1 is 6, so those cancel, so we end up with 6 choose 3 is 20. Alright, so next what we can do is we want 3 girls out of the 4, so now we do 4 choose 3, which is 4 factorial over 3 factorial times 1 factorial. So if we expand, we get this over this. So obviously 1s just don't matter. Then these cancel, so we get that this is 4. So the total number of outcomes that work is 20 times 4 over the total number of outcomes, which is 10 choose 6. So we have 10 choose 6, which is 10 times 9 times 8 times 7 times 6 times 5 times 4. All of that over 6 factorial times 4 factorial. So then this cancels. We cancel 6. We cancel this 5 and 2 with a 10. We cancel 4 with 8. And cancel 3 with 9. Which leaves us with a total of 3 times 2 times 7 times 5, which is 210. So the probability will be the number of outcomes that work over the total number of outcomes, leaving us with an answer of 8 over 21. Alright, let's do a second practice problem. Let's say that now we have 7 boys and 4 girls. And again, we want the same 6-person committee with the same number of boys and girls. So what is the probability now? I'll give you a few seconds. This might be where you pause the video. Alright, so let's work through this. So we have 7 boys, so again we want to choose 3 of them. So we have 7 choose 3, which is this. So again, we can cancel this 4 because there's a 4 factorial in here. So we do this, which leaves us with 35. So now we do this, which is again 4. So we have 140 over 11 choose 6, which ends up being something like this, which cancels down to, which looks like 11 times 2 times 3 times, not 2, because that got canceled, times 7. Which is 462, which leaves us with the probability of 140 over 462, which simplifies down to 20 over 66, or 5 over 30. Wait. No, hold on. That's 10 over 33. My bad. So 10 over 33. Alright. Let me give you a third practice problem, but this time I'm not going to show you the answer or work it out in this video. What I want you to do is work it out by yourself and leave your answer in the comment section so that I can check it later. So now let's say that we have, again, 7 boys and now 5 girls, and now we have an 8-person committee. So how many ways are there to have an equal number of boys and girls? Thank you for watching. I hope you learned something about combinations. Please like the video, subscribe to the channel, and I will see you later. Bye!